Okay, so we're going to talk about how we solve a system in 3 variables. And when we say solve a system in 3 variables, we are actually meaning 3 equations that are 3 variables, right? The number of variables tells you how many equations you need in order to solve, okay? And the real question here is, how in the world do we solve these things? What I want you to do is I want you to write down this example as I go through it, okay? I'm going to try and take you step by step through just one example. Here is a system of 3 equations. Now before I even start on this one, I happen to know there is another, or your book takes you through an example on page 221. There's another example of how to solve one. Okay? But in my case, this is negative x plus y plus 2z equals 7, 2x plus 3y plus z equals 1, and negative 3x minus 4y plus z equals 4. Okay? I have 3 variables, x, y, and z, so I have 3 equations. I like to number my equations because then it helps me keep track of them, and I can kind of reference them by their numbers. Here are the steps to solving. The first step is to eliminate one variable. It does not matter which one you choose to eliminate. I am going to tackle this problem by eliminating z. Reason is I see this 1z here, and to me, anytime I got that 1, that's pretty easy for me to make opposites with, because I'm just going to multiply. So I'm going to eliminate one variable and try and get 2 equations with 2. I'm going to change my 3 by 3 to a 2 by 2. The goal is to reduce by one full equation. To do this, I'm going to look at equation 1 and equation 2. Okay, equation 1 is negative x plus y plus 2z equals 7. Equation 2 is 2x plus 3y plus z equals 1. Now, I said I want to eliminate z. So what I'm going to do is I'm going to multiply this bottom equation by negative 2. Because now I get negative 4x minus 6y minus 2z equals negative 2. Okay, so I just took these 2 equations and I decided I was trying to get rid of z. The top one's just going to come over as is. Don't need to change that. That already has a positive 2z that matches with my now made negative 2z. Okay, so now I'm going to go to work. The goal is that the z's are eliminated. Negative 5x minus 5y equals positive 5. Great, love it. This is actually now equation 4. This is why I number them, because holy cow, we got a lot going on. I've made one equation with just 2 variables in it. Now I need to make another. 2 variables, 2 equations. Okay, so now I'm going to look at 2 and 3. Okay, why 2 and 3? Those are the ones I picked. Okay, those ones felt like they would be easy to cancel. What I liked about these 2, I liked that I had plus z in both. Okay. To me, that made it easier because then all I had to do was multiply the bottom one by negative 1. So I got positive 3x plus 4y minus z equals negative 4. That minus z is the opposite of my plus z up on top. Okay? The z's are going to cancel. That was the goal. And I have a 5th equation. Okay? Now, if you look at equation 4 and equation 5 together, that is a good sign. And what is so good about that is I have a 2 by 2 now. Okay? So we've eliminated one variable. And now using 4 and 5, we're ready to eliminate another variable. And that's step 2. You reduce to a 2 by 2. And now you're going to go through another round of elimination to eliminate another variable. So now that I'm on my second step, I'm working now in my 2 by 2 with 2 variables, 2 equations. Okay? So one of my equations with 2 variables was negative 5x minus 5y equals 5. The other one was 5x plus 7y equals negative 3. Already, we're pretty pumped. This is set up for elimination so well. Look at that! Look at the x's, they're gone. We didn't actually have to multiply. And what we're left with is 2y equals 2. Y equals 1. Okay, the third step is to get one of those variables. So now that we know y equals 1, then we kind of have to work backwards. We're going to use one of our 2 by 2's to get a second variable. And when I say a second variable, I want to go with the one that I had just eliminated. So I can pick from either equation 4 or equation 5. I hate negatives. Negatives are the worst. So I'm going to use equation 5. Okay, so I see equation 5. And equation 5 says 5x plus 7y equals negative 3. But now, y equals 1. So 5x plus 7 times 1 equals negative 3. And so I'm going to take this all the way through and I'm going to solve it. I need a little more room. This is a long process. There's not a lot of homework problems for you. Okay? So we've solved for another one. Okay? And then the final step is to solve for the last variable. And in order to do that, we have to go all the way back up to the top. Pick either equation 1, equation 2, or equation 3. Okay? And so we're back in our 3 by 3 to get the last one. I'm going to pick equation number 2. Okay, I hope you have these written down. I'm going to pick equation number 2. 2x plus 3y plus z equals 1. And so then, I'm going to substitute. I know that x is negative 2. We just solved for that. I know that y is 1. And now I know that I'm going to have to work to get z. Okay? Z equals 2. That means my solution is negative 2, 1, 2. X, Y, Z. That is a long process. I'm going to run through it for you real quick. So, a little run through. We started at the top, and we said we had to get rid of one variable. We were up here. This was a 3 by 3. 3 equations, 3 variables. And we said, we can't do this. This is too much. So we had to work it down to get to a 2 by 2. What we did to do that was eliminated one variable. We went through 2 elimination processes to get 2 new equations that were only 2 variables. Okay, lots of the word 2. Then, with that 2 by 2, you guys are professionals. That elimination right there was kind of a walk in the park. Not too difficult. Okay? So then, once we had that, we could solve that, right? We could solve this pretty easily. And we got y equals 1. So then, just like we've been doing before, we replaced y in one of the equations and solved for a second variable. And then we were back up at the top to get to the third variable. Okay? And so we slowly work our way down so that we can slowly build ourselves back up. This step 2 and step 3, whoops, that was not a straight line this one. Let's try this again. Step 2 and step 3. Neither was that. Whatever. Anyway, step 2 and step 3 should be familiar. If I had just given you that problem, you could do it. It's the first step and the last step that's what's new. Okay? The first step and the last step are what are new here and what is a little bit different for you. Okay? I'm going to show you it in a little bit different way. You have 3 equations, 3 variables. And then you eliminate one so that you have 2 equations, 2 variables. And then you solve one. You get a variable. Then you replace that variable, so now you have 2 variables that you know. You know what they equal. And then you go back to the top, and then you're back at 3. So you have to work your way down so you can build yourself back up. Okay? It is a tricky process. I know it's a tricky process. I know that probably confused you even more, but I know you will be able to do this. I also know that it's going to be a challenge at first. Okay? You have 6 problems to practice with. Okay? So there's not a whole lot. We just need some practice. Okay? I hope you wrote this down. I hope you kind of followed what we were doing. Notice we did lots of numbering of equations. We could have, in number 1, we could have used 1 and 3 together, but we didn't need to. We only had to work with 2 eliminations to get 2 new equations with only 2 variables. Okay? And then in number 3, we solved for that second variable. Once we had y equals 1, we just replaced and went back to what x equals. And then to finish it, we had to go back to the top. Every answer should be an ordered triple. Okay? Every answer should be an ordered triple. This is the process. Elimination. Okay? You can do it. I know you can. Make it happen, people.